Hello, grade 8s. We've wrapped up our chapter on linear relations, and our next one is actually related to that. And so we saw how when we had two quantities, and most of the time we were looking at x and y, if we made a table of values and plotted those points, and if they formed a straight line, we said that was a linear relation. And linear relations are very, very closely related to linear equations, which is what we're talking about today. And yeah, so we used some different words in our last chapter. We used words like expressions, where we didn't have an equal sign. And that really is the big difference between this chapter and the last, is now we're going to put in that equal sign, and we are going to solve for a variable. And what is a variable? We're going to find out very shortly. So yeah, so we're looking at these equations. We're going to see an equal sign, and that's if we have one thing equal to another thing. Equals, kind of think of it as the same as something else. Then it's going to give us something to solve for. So a couple examples. 2 times x equals 3, that would be an equation, has an equal sign in it. B equals 6 is also an equation as well, just saying that b is exactly the same as 6 in this situation right here. Again, I just want to highlight the fact that in grade 8 we're trying to avoid using x's to represent multiplication, especially in this topic on linear equations. We're going to be using x as a variable in many cases. So yeah, we're kind of getting out of the habit of using x to represent multiplication for that very reason. We don't want to confuse it with one of our variables. So in the equation 5x minus 2 equals 9, there's just some vocab that we need to talk about. The first word is a coefficient. And a coefficient, I just kind of think of it as a number that multiplies a variable. So in this equation, the number that's multiplying our variable is the 5 right there. That would be called our coefficient. Might be a new word that you're maybe not used to, but you will hopefully get familiar with it as we go along. A constant term, or a constant, is just a number all alone by itself that's not attached to any variable at all. So there's two constants in this equation. We got a -2 and a 9, and just something to keep in mind, the sign directly to the left is always applied to that constant as well. So probably the biggest mistake that people make in identifying that constant is saying, oh yeah, that's easy, the constant is 2, but we also need to use that sign directly to the left. And whether we think about it as -2 or -2, it really comes down to the same thing. We can think of it either way, and those two things are kind of, well, they are equal in a way. The variable is just some type of letter or symbol that's representing a number. In this case, it is an x, and in many cases, the most common variable used is x, but it really could be anything. It could be any letter. It could be, I don't know, a Greek letter. It could even be a picture. It doesn't have to always be an x. Okay, in a very similar way to linear relations, if we can plot the points and make a graph based on these equations, and if they form a line, it's got to be a linear equation. So 2 examples up here on the board. Okay, so our main goal and what we really want to do in grade 8 is solve some of these. And so there's 3 methods that I want to talk about today. Number 1 is inspection. And when you get into your textbook questions and assignments, I really want you to read carefully, and because different questions are going to ask you to solve these equations in different ways. And so please solve it in the way that is being asked of you. So if it says solve by inspection, in a way it's kind of nice because there's not really any work that I need to show for this. I just kind of think of this in my brain as I have 4 times some number, and that equals negative 12. And so now that we know a little bit more about integers, we're in a position where we can maybe mentally, using some mental math, solve this problem. So I'm thinking in my brain, what number of x could go there to make that statement true, to have those two sides be equal. And so the first question I might want to ask myself is, I've this 4, there's no sign in front of it, that means it's positive. So I have a positive 4, and what must x be such that I can get a negative 12? And I'm going to think back to my sign rules. I'm like, oh yeah, the signs need to be opposite in order to get a negative result. So I know x, I know it has to be negative, because I learned my sign rules a couple of weeks ago. And so that's helping me out right now. And then I need to get the 12. So I'm thinking 4 times what number is going to give me 12. So I'm relying on hopefully my knowledge of times tables. 4 groups of what number is going to give me 12, and it's 3. And so maybe based on some prior experience, or maybe just know your times tables in your brain, that can help you when solving by inspection. Next one's a bit trickier. I don't know, because maybe most people find dividing a little bit harder than multiplication. But I think still doable by inspection. We have t being divided by 2, and this equals negative 9. So again, I'm using my integer rules, and I have a negative quotient. Quotient, just a fancy word, meaning the answer to division. So I got a negative 9 there, and so I'm thinking the same way. My sign's got to be opposite here to get a negative. So if that's positive, I know I need a negative number on top. And so then I'm just thinking, what number, if divided by 2, would give me 9? So could it be 10? I might do a couple checks in my head. 10 divided by 2 is going to give me 5. Maybe it'll go up a few. Maybe 14. Maybe 14 could work. 14 divided by 2. Oh no, wait, that's 7. Maybe 18. 18 divided by 2 would give me 9. So I'm going to say negative 18. And that's kind of how I solve by inspection. I'm relying on some previous knowledge of integers and times tables. The second method is using models. And so I want to start you guys with being familiar with algebra tiles. And we got some integer chips things. I guess they're not chips, but and we're going to be using these a lot next year as well, these algebra tiles. And so in order to show modeling, we need to know how to draw these. So we have this guy right here, this filled in green rectangle that represents a positive variable. An empty one or a white one represents a negative variable. So this could be like a positive A or a positive D or a positive apple. It could be really anything. And this one here could represent a negative X, a negative Y, a negative Z. It's some type of negative variable. These are whole numbers. Red means +1 and white means -1. And so but I guess if you're just using a pencil and paper, oftentimes you can just think of it like this as well. If you have a rectangle and you fill it in, that's going to be your positive variable. And if you're using a pencil and paper and you just draw that and don't shade it in, unshaded is going to be negative, your negative variable. And to do this using just a pencil, I would just draw a tiny square, and that one's basically the same. So Those are our algebra tiles, which you must use if the question says solve the following equation using a model, you must do it this way. So, if I'm solving these using models, I want to show 4 x's on one side. So I know my x's look like this, but if I'm just using, well, if I just leave it like this, this represents negative 4x. So I wonder if I got green in here somewhere. Maybe I can make these. So if you want to get super fancy and get your pencil crayons out or felt or whatever, I guess you could do this too. Otherwise, just shade them in with your pencil. If I was a student, I'd probably just do that just because it's a lot faster. But I know some of you want to make it look professional, so if you want to do that, get your felts out. And so this is equal to, this amount is going to be the same as negative 12. And so watch how I start stacking these negative 12s, because I'm going to do it in a way that hopefully means something to you. So I'm going to start here. And I stacked them 4 high. And there's a reason for that, because my variables were also stacked 4 high. I could keep going and keep stacking them until I get to Jacqueline's protractor up there. But I'm going to stop at 4 and then start making a new column. Because I think stacking them this way is going to help me figure out what one of the x's is worth. And so that's kind of our goal in solving these equations, is we want to figure out what one of these x's is worth. Or what is it equal to, or what is it the same as. And it looks like one of these guys is equal to 3 here, in my opinion. So I'm gonna circle this, because it helps me to solve this equation. One of these x's is worth negative 3. Because this x has also got to be the same as negative 3, this one's got to be the same as negative 3, and this one the same thing. And so I can hopefully draw that conclusion. One of these x's is also the same as negative 3. Okay, the next one's a little bit trickier because we're dividing. And so I got some positive variable, but I only got, it's being divided in 2. So if I was to shade this in, I only got half of it. So this is the half that I have right here. That half I do not have at this point. And I know this is equal to negative 9. In this case, I don't know, I know there's only a stack of 1 here, but I'm just gonna make another stack of 3. In this case, it doesn't really matter how I arrange them. So the question is that I'm asking myself is, if I had a full x, if I know that this half is the same as negative 9, if I had the whole thing, what would I have to do? Well, if I know that half is equal to negative 9, if I had the other half, that would also be another negative 9 over here. So once I add this piece, I got to add another negative 9. So that everything balances out. And so this t is equal to negative 18, just like we saw in on the last slide. Okay, so I think, are we going to get into my favorite books? Okay, a couple of my favorite books that I'd like to talk to you guys about today. Some novels or self-help books. We got The Loner, another book called The Loner, and even one more book called The Loner. It's a very famous and popular title of a book. And the reason why I like it so much is because it reminds me that I want to get these variables alone. I don't want them to be attached to any other coefficient or anything else. In the end, I want them to be alone by themselves. I want them, a couple other things too. I also want them to be positive. I don't want to end up with a negative, I don't want any negative signs attached to my variables in the end. And maybe that's good for now. A couple other books, How to Be Alone and The Art of Being Alone. Yeah, this is going to be very artistic once you guys, for those fancy students that get out their felts and color in their algebra tiles, there is going to be some art involved as well, maybe. And so, we're in our last way of solving them, it's by isolation, by getting these variables alone by themselves. No negative signs and no coefficients attached. And so we're going to do this by using something called opposite operations. So there's two sets of our operators in math, our operations are plus, minus, multiply, divide. And there are two sets, there are two that are kind of related to each other. So addition and subtraction are related, and multiplication and division are related. If you guys think about your fact families from a long time ago, like 2 plus 3 equals 5, but also 5 minus 2 equals 3, and 5 minus 3 equals 2, they kind of form like this nice fact family. And so that's kind of what I mean by they're related to each other. And so, but knowing this, knowing that addition and subtraction are related, multiplication and division are related, these ideas are going to help us get these variables to be alone. We're going to isolate them using this. So let me show you a couple examples of how this might work. So in this case, I have negative 5r equals negative 40. And so again, my goal is for for this variable to be all alone. So if r is being multiplied by negative 5, I want to use the opposite operation. I want to use the opposite operation to undo this. And in another way, I might think about it as making zeros and ones. And so when we're talking about multiplication, division, that's happening to our variable, in a way I kind of want to make a 1 here. I'll show you what I mean in a second. So if r is being multiplied by negative 5, I want to choose the opposite operation to multiplication, which is division. So I'm going to divide both sides by the same thing, because I want to keep things in balance. And again, I want to divide both sides by something in such a way that r can be alone, so that my variable can be by itself. And I'm going to pick negative 5. Why is negative 5 helpful in this case? Well, any number divided by itself is 1. So if you had like negative 16 divided by negative 16, that's 1. If you had 2,000 divided by 2,000, that's also 1. So by having the exact same number being divided by itself, that gives me a 1. Which is really great, because anything now, if this simplifies to a 1, this basically means 1 times r, which is just r. And then I just have to go negative 40 divided by negative 5, which is 8. And you've done this before in grade 7 and maybe even grade 6, but maybe more with addition and subtraction. But essentially, we're also kind of doing the same thing as well. Like let's say I had this. 5 plus r equals 10. I can also think about using opposite operations in this case as well. Except in this case, I have this plus 5 on this side, and I would want to undo it by going, I want to take away 5. And I'd want to take away 5 here. And that would make, in this case, not a 1, but a 0, leaving r all by itself. And having a plus r by itself is okay, because that can just be written as r. It's still alone, isolated. Let's try another one. We got 7 being multiplied by c equals negative 14. So if c is being multiplied by 7, I want to think, oh, what is the opposite to multiplication? It's division. So I need to divide both sides. Why am I dividing both sides by something? It's because I need to keep everything in balance, and hopefully but those models earlier helped to explain that. So what I'm doing to one side, I'm doing to the other. So I'm dividing both sides by 7. The reason is 7 divided by 7 just gives me 1. Or in other words, they just cancel out. I'm left with c equals negative 2. Last one here. In my last example, I have x being divided by 2. So my variable is being divided by 2, so I want to pick the opposite operation to that. The opposite operation to division is multiplication. So I want to multiply both sides by 2. So I guess if I think back to the multiplication of fractions, 2 times x over would leave me with 2x over 2. 8 times 2 is 16. If I see any number over itself, this is just making a 1, and I'm left with x equals 16. That's all. I will give you guys some questions to try on your own. Hope it goes well. Please contact me if you have any questions. Thank you. Bye.